Okay, so let's take a look at some of the solutions for tutorial 2. Okay, we won't go through everything because a lot of it is pretty similar, but just a few important ones that you do need to know. Okay, so let's take a look at 1.1. So we're given the function f of x, and that's equal to the integral from 0 to x, the square root of t plus t cubed dt. Okay, and we want to find the derivative. So f prime of x is going to be d by dx of the integral from 0 to x, square root of t plus t cubed dt. Okay, like I said in the lecture videos, we are differentiating with respect to x, and we have a single x in the upper bound. So only x here. Okay, so since we only have an x over there, we can use FTC part 1. So the derivative and the integral are going to cancel, and we just left with the function evaluated at x. So it's going to be x plus x cubed. So wherever there was a t, we now evaluate that at x. Okay, so that's the simple fundamental theorem of calculus part 1. Okay, let's take a look at 1.2. So here we have f of x is equal to the integral from 1 to x cos of t squared. So the integral from 1 to x cos of t squared dt. Again, we want to find the derivative. So f prime of x will be d by dx, the integral from 1 to x cos of t squared dt. Again, we're differentiating with respect to x. We have a single x in the upper bound, so we can use FTC part 1. So we just take the integrand and evaluate it at x. So now it becomes cos of x squared. Okay, are there any questions so far? Okay, just for those that have just entered the meeting now, if you are unregistered and you have not told me yet that you are unregistered, please do so as soon as possible. Okay, because remember, you've got the tutorial test at 10:30. If you don't tell me that you are unregistered, the system is going to give you a default mark of 0. Okay, we don't want that. So I really need a list of all the unregistered students so that you don't automatically get 0. Okay, we don't have a list. You have to let us know that you are unregistered. Okay, and also please tell all of your friends that are unregistered. Okay, they have to tell me as soon as possible so that they don't get 0. Okay, I only have 4 students that have told me so far. Okay, so they won't be getting 0, but if you don't let me know before 10:30, there's not much more that I can do. Okay, so please let your friends know. Okay, so next one is 1.3. Okay, let's have a look at that one. Okay, so 1.3, this one's a bit different. Now x is at the bottom. Okay, so it's a bit different here, but we're going to use the same sort of thing. I got the chat here. Does the class start at 9:30 or 9:35? The class starts at 9:30. Okay, so please try to be here at 9:30. Okay, so we have f of x. Sorry, f of x is equal to the integral. So now it's from x up to 2, t cubed sine of t dt. Okay, so now as it is here, we can't use FTC part 1 because the upper bound is not x. But we can swap the bounds, but remember we need the minus sign. So it's going to be minus the integral from 2 to x t cubed sine of t dt. Okay, so we swap the bounds, but now we need the minus sign. Okay, so there's the minus sign in front there because we swapped the bounds. Okay, so now we can find the derivative. So f prime of x is going to be d by dx of minus the integral from 2 to x t cubed sine of t dt. Okay, so we just take the derivative, and notice we're taking the derivative with respect to x. The upper bound is x, so we can use FTC part 1. So this now becomes minus x cubed sine of x. Again, we've just used FTC part 1. Okay, are there any questions so far? Okay, no questions so far. Awesome. Let's take a look at the next one. 1.4. So here we have f of x is equal to the integral from 2 to 1 over x sine to the 4t dt. And we want to find the derivative. So we just do this. F prime of x is equal to d by dx, the integral from 2 to 1 over x sine to the 4t dt. But now we have a problem. We see that the upper bound is not just x. Okay, so it's not x in the upper bound, it's 1 over x. So that's going to be a problem. So what we need to do is do a little substitution so that the upper bound is just a single variable. So the way that we do that is we say u is equal to 1 over x. Okay, so we need to now use the chain rule. Because remember, just make a little note on the side here, d by dx is now going to become d by du. Okay, but then we also need du by dx. So if we have df by dx, it's going to be df by du, du by dx. Remember the chain rule? Okay, so that's what we're going to do here. Instead of doing df by dx, we're going to do df by du, but remember the chain rule says we also need du by dx. So this is going to become d by du of the integral from 2 to u sine to the 4t dt, but then we also need du by dx, okay, because of the chain rule here. Okay, is there anyone that's not following with that step? Okay, so we've just introduced this u variable so that the upper bound becomes a single variable. But now we need to use the chain rule because df by dx is now df by du and then du by dx by the chain rule. Okay, so that's all we've done over here. Okay, now this first part over here is easy to do because that's just FTC part 1 because we've got d by du and the upper bound is just u. Okay, so that's just the chain rule. Sorry, not chain rule, FTC part 1. So this is going to become sine to the 4u. That's the first part. What about the second part? Du by dx, that is the derivative of 1 over x. So that's going to be minus 1 over x squared. Okay, but we're not done yet because here we have a u, but here we have an x. So we want everything in terms of x. Okay, so we want everything in terms of x. So instead of u, I'm now going to put 1 over x, because that's what we had over here. Okay, so this is going to become sine to the 4, 1 over x times minus 1 over x squared. Yeah, and that's going to be our derivative. So you see, it's a bit more complicated because we've got a function of x in the upper bound, but with a little bit of substitution and using the chain rule, we can see we can easily find the answer. Okay, are there any questions about this substitution procedure?
Yes, so please repeat from the second to last step.
Second to last, okay, sure. So in this yellow box, we've got the FTC part 1, because we've got d by du, and then the upper bound is u. So there and there. So if that's the case, then we just use FTC part 1, which means the derivative and the integral are going to cancel, and we're just left with the function evaluated at the upper bound. So the function was sine to the 4t, but we just evaluated at the upper bound now. So it becomes sine to the 4 of u. Okay, but we can't have u and x variables. So in this last line, we replace u with 1 over x, because that's what we put over here. U is 1 over x. Okay, so now everything is in terms of x, which is what we want. Okay, does that help?
Got it.
Okay, cool. Yeah, so this first part will give you a function in terms of u, but we just want everything in terms of x. So we have to replace u with whatever we made. So here we have u equals 1 over x, so we just do that replacement. Okay, let's have a look at some of the problems from question 2. Okay, so
Sir.
question, yes. Yeah.
Could you do 1.5 if it's possible?
1.5, sure. I didn't want to cover everything just because of time. We only have 40 minutes to go over everything, but sure, we can do that. So 1.5. This was the integral from 1 to 3x plus 2. Okay, so let's write that down. So f of x was the integral from 1 to 3x plus 2, t over 1 plus t cubed dt. Okay, and we want to find f prime of x. So that's going to be d by dx of the integral from 1 to 3x plus 2, t over 1 plus t cubed dt. Again, we've got this problem because this is a function of x. It's not just x. Okay, which means we have to use a substitution to make that upper bound a single variable. So what we do is we let u be equal to 3x plus 2. But now, since we've introduced this variable, we're going to have to use the chain rule, because df by dx is now going to be df by du, du by dx, because of the chain rule, because of this, this variable that we've introduced. So this is now going to become d by du, the integral from 1 to u, t over 1 plus t cubed dt. So that's this first part of the chain rule. Now we need the second part of the chain rule, and that's just du by dx. Okay, so let's put all the pieces together. So this first part, notice that we are differentiating with respect to u, and the upper bound is u. So that means we can use FTC part 1, which states that the derivative and the integral are going to cancel, and we are left with the function evaluated at the upper bound. So it's going to be u over 1 plus u cubed. Okay, what is du by dx? Well, u is equal to 3x plus 2. So du by dx is going to be 3. But we're not done yet. We need to put x back. Okay, so remember, u is equal to 3x plus 2. So this is going to be 3. Sorry. This is going to be 3 times 3x plus 2 divided by 1 plus 3x plus 2 cubed. Okay, and you can leave it like that. Don't try expand this out or simplify. Just leave it as is. Okay, are there any questions about 1.5?
So is it a must to use the U, like the chain rule? Do you have to?
Which other method would you use? Do you know another method?
No, I don't have another method, but I just went on with the steps and never used, like I didn't let the U become 3x plus 2.
No, you have to, because with FTC part 1, remember this derivative here. If it's the derivative with respect to u, this upper bound has to be a single variable. So you can have d by dx and then the integral from 1 to x, or you can have d by du, the integral from 1 to u. But the important thing is that this upper bound has to be a single variable. It can't be a function like in the previous step. So that's why we did.
So I can't say d over d, and then instead of putting u, I just put the 3x plus 2 as it is.
No, you can't do that. It has to be a single variable at the top, single variable at the bottom.
Okay, well, thank you.
Sure, no worries. Any other questions? I see someone else put their hands up.
Yes, greetings. I solved this problem using another method, not this one.
Okay, did you get the same answer?
Yes.
Yeah, no, that's perfect then. You can use whatever you like. As long as you're getting the right answer, I'm happy.
Okay.
But remember, if you are using a different method, make sure you show all your working so that I can see, what you're doing. Because something like this, it might be out of 3 marks or something. If you're just writing the answer down, I can't give you all the marks. You have to show all the working in that case.
Yes, I did show all the working parts. It does not require chain rule and all these other steps that you did, but I did it different.
Okay, I think I know how you did it. Let me just go here. Okay, so your method, I think it's this one, correct me if I'm wrong. We have f of x is equal to the integral from 1 to 3x plus 2. I'm just using this as an example, over 1 plus t cubed dt. And you want to find f prime of x. Okay, so I think you're using this method, but let me know if it's different. So the way that you would do this is you would use, FTC part 2, and you would say that this is the antiderivative at 3x plus 2 minus the antiderivative at 1, right? Where f is the antiderivative of this. Okay, so you use FTC part 2 for that. Sorry, this is f. Then f prime of x would then be d by dx of this minus d by dx of this. Okay, but the f of 1 is just a constant, so that goes away. So this now becomes f prime of 3x plus 2. But this has an outer function and an inner function. So we need the chain rule. So this will be d by dx 3x plus 2. Okay, the derivative of the antiderivative is just the function again. So that's going to be the function, this function, but evaluated at 3x plus 2. So that would be 3x plus 2 over 1 plus 3x plus 2 cubed. And then the derivative of 3x plus 2 is 3. Okay, so I think this is the method used by the organic chemistry tutor, I think, on YouTube. But it's exactly, you use this one.
Yes. Yes, sir.
So over here, we are still using the chain rule. Okay, so you can't get away from using the chain rule. You have to use that still. Okay, but please be careful of this method, because here, when you're writing this capital F, this capital F is not the antiderivative of the function given. This capital F is the antiderivative of t over 1 plus t cubed. Okay, because you're using FTC part 2. So that's where this capital F comes from. You have to say this on the side. Okay, this little statement in blue, you have to say that on the side so that I know where you are getting capital F from. Okay, so if you're using this method, you can if you want to, no problems there, but you have to write this blue thing on the side with your working, or else I don't know where you're getting capital F from. Okay, if you don't write that down, then you're going to be losing marks because you're not showing all of your working. Okay, so it's very important that you have this written down on the side. Okay, so I know where it comes from. Okay, because you don't want to mix up this little f that I gave you and this capital F that you're writing down. We don't want to mix those up. Okay, so please put that blue writing down on the side. Okay, but this method is fine. I have no problem with that. Okay, are there any other questions about which method you can use? Okay, cool. Let's take a look at some of the questions from question 2. Okay, so this was using FTC part 2. Okay, so let's just go through a couple of these. Okay, so for 2.1, we're given the integral from 1 to 3, x minus 1, x squared plus 2x minus 4. Okay, so as it is, we can't find the antiderivative, but if we expand this out, then we're going to get a polynomial. So that will be easy to use. So this will be the integral from 1 to 3. If I distribute the x into everything, I'm going to get x cubed plus 2x squared minus 4x. Then I distribute the minus 1 to everything. So I'm going to get minus x squared minus 2x plus 4. Okay, so everything is a nice, the integrand is a nice polynomial, so we can deal with that. Okay, so let's just collect the like terms. So we're going to get x cubed plus x squared minus 6x plus 4 dx. Going too fast. Okay, sorry. My Zoom sessions only last 40 minutes and then we get cut off. So, you know, if we want to get through as much as possible, I need to go a bit quick. Okay, but I can slow down, but then, you know, we can't get through everything. Okay, so let me just repeat for this then. So we've got this integral and we've got a product of 2 brackets. Now, we can't find the antiderivative straight away, okay, because it's a product of things. So we have to multiply everything out. So first we multiply the x into everything. So then that gives us this first bit. Okay, then we multiply the -1 into everything, and that gives us the second bit. Okay, now we just collect the like terms. So we've got the x cubed, 2x squared minus x squared, that's going to give us x squared, minus 4x minus 2x, that's going to be minus 6x, and then we've got the +4 left over. Okay, so now this is a simple polynomial. We can use the antiderivative power rule to simplify things. So we do the antiderivative power rule for the first term. We add 1 to the exponent to make it 4, and then divide by 4. So this is going to be 1 over 4, x to the 4. For the next term, we add 1 to the exponent to make it 3, divide by 3, we get 1/3 x cubed. For the next one, we add 1 to the exponent to make it 2, divide by 2, so we're going to get minus 3x squared. Okay, and then for the last one, we just have 4. The antiderivative of 4 is going to be 4x. So we have plus 4x. Okay, and then this is evaluated from 1 to 3. So now we take our antiderivative, we evaluate it at 3, and then we subtract the antiderivative evaluated at 1. So we're going to get 1/4 3 to the 4 plus 1/3 3 cubed minus 3 times 3 squared plus 4 times 3. Okay, so that is the antiderivative evaluated at the upper bound. Now we need to take the antiderivative evaluated at the lower bound. So that's minus 1/4 1 to the 4 plus 1/3 1 cubed minus 3 times 1 squared plus 4 times 1. Okay, so that is the antiderivative at the upper bound minus the antiderivative at the lower bound. Now we can simplify all of these terms. So the first one, we're going to get 81 over 4 plus 9 minus 27 plus 12. Okay, so that's for the first bracket. Then for the second bracket, we're going to have minus 1/4 minus 1/3. Okay, and then, minus 1/4 minus 1/3 plus 3, and then minus 4. Okay, so next we can just collect the fractions together. We're going to get 27 minus 27 plus 9, and then plus 3 minus 4. That's going to be 20 plus 9 minus 27 plus 12 we got there, minus 1, and then minus 1/3. I'm just collecting terms together to simplify this. So 20 plus 9, then minus 27 plus 12 minus 1. If you add all that up, we're going to get 13. And then we're still left with the minus 1/3. Okay, and then 13 minus 1/3. We can times by 3 to make this 39 minus 1 over 3. And then that's going to give us 38 over 3. Okay, so then that's our final answer for that one. Okay, are there any questions about this? Okay, so not too bad. Okay, let's look at the next one. We have the integral from -1 to 1 of x to the 100. Okay, so this is 2.2. We have the integral from -1 to 1 of x to the 100 dx. Okay, so again, we just use the power rule. So we add 1 to the exponent and then divide. So 100 plus 1, that's going to be 101. We divide by that, and we have x to the 101. And this is evaluated between -1 and 1. So we can take the 1 over 101 outside, and we're left with 1 to the 101 minus, and then -1 to the 101. Okay, so I've just taken the function evaluated at the upper bound minus the function evaluated at the lower bound. So this is going to be 1 over 101. 1 to the power anything is just going to be 1 minus, and then -1 to an odd number is going to be -1. So this will be 1 minus -1. Okay, so we have 1 over 101. 1 minus -1 is the same as 1 plus 1, so we have 2. So we end up with 2 over 101. Okay, any questions about this one? Okay, so it's not too bad with the power rule. Okay, let's look at the next one, 2.3. Okay, so we have the integral from 0 to 1, the fifth root of x to the 4 dx. Okay, so now as it's written, we can't use the power rule because we've got an exponent and we've got a root. Okay, so that's messing it up a bit. So instead, we're going to write this as the integral from 0 to 1, x to the 4 over 5. Okay, so this power and this root, we've combined into one exponent. Okay, so now that it's a single exponent, we can use the power rule. So we're going to add 1 to the exponent. So that's going to make it 9 over 5. Then we need to divide by 9 over 5, but that's the same thing as multiplying by 5 over 9. So that's going to be 5 over 9, x to the 9 over 5. And this needs to be evaluated from 0 to 1. Okay, so first we evaluate at the upper bound. So this is going to be 5 over 9, 1 to the 9 over 5, minus 5 over 9, 0 to the 9 over 5. Okay, so antiderivative evaluated at the upper bound minus antiderivative evaluated at the lower bound. So we're going to get 5 over 9 minus 0. So that's just going to be 5 over 9. Okay, any questions about this one? Okay, so everyone's okay with exponents and roots and all that. Okay, cool. Let's look at the next one, 2.4. So here we have the integral from par to 2 par of cos x dx. Okay, so same as before. The function is cos, so we need to find the antiderivative. So the antiderivative of cos is going to be sine. So we have sine x. This needs to be evaluated from par to 2 par. Okay, so we take the function evaluated at the upper bound. So it's going to be sine of 2 par minus sine at par. Okay, so sine evaluated at 2 par, that's going to be 0. Sine evaluated at par, that's also going to be 0. So 0 minus 0, that's going to give us 0. Okay, any questions about this one?
Yes, what if we left it at sine 2 pi minus sine pi? Would it be incorrect or?
You would only get part marks. So we need to evaluate the trig functions to get all the marks.
All right, thank you, sir.
Sure. So if you leave it there, you'll get 1 mark for the antiderivative and 1 mark for that. So you'd get 2 out of 3. Okay, the last mark, that's your final step here to make it out of 3. Okay, there's only 1 minute remaining, so that's all the time we have today. I will post the tutorial quiz on Learn 2022 at 10:30. Okay, so you know where to find it. It's under the submission, that submission button for summative tutorial quiz. Okay, so just have a look at that at 10:30. You will have 1 hour to complete it and then half an hour to submit it. Okay, those that are not registered, if you have not let me know yet, please let me know as soon as you can so that you don't get 0. And please tell your friends to do the same. If you don't let me know by the end of today, I can't help you if the system gives you 0. Okay, so I really, really need that list as soon as possible.
Sorry, sir, if you don't mind
Yeah.
me asking, how many questions do we have for the tutorial?
I think there are a couple, I think there's 5 questions or so, but it's just out of 15. There's really, it's not a big test. It's just out of 15.
Thank you, sir.
So
Sure.
may we please do 2.5 on, can you please send us 2.5 on WhatsApp?